Everyone, welcome to the next Earth and Space Science Regents exam. This is going to be for August 2025. If you didn't see our June 2025 video, you should definitely check that one out. The more of these that you can get under your belt, the better off that you're going to end up doing when you take it yourself. The June 2025 Regents was very reading heavy. I did not take this one yet, so you're going to see me take it on the fly. We'll figure it out together. I definitely recommend the best way to use this video is to do this yourself first, and then come and watch the video and watch me go through it so you can really get the full effect. Or you can kind of do it with me. You can have it out and then you can, pause it, do question one, and then play it and then see me solve question one and just go through it with me. See how you do. All right, so let's go down here and we're going to start with number one. It's really important you read everything on these tests. So obviously this stuff up here is instructional, so I'm not going to waste my time there reading it to you, but you should read it anyway. So we're going to start with the first cluster here. It says energy in the sun. The sun's energy influences the environment of all celestial objects in our solar system. So just as we go, you should really probably highlight stuff celestial right there. That means like space-like object. Different forms of the hydrogen and helium atoms contained in the sun's core, deuterium and the helium atom, are under very high temperatures and pressure. These atoms combine to form helium while releasing tremendous amounts of energy. Okay, so they're just saying things like helium, very high temperatures and pressure. That's kind of all I would highlight right there. We got the layers of the sun. You can see photosphere, convection zone, radiative zone, and the core of the sun there. And it seems to be giving us some information about the layers. Now, remember, I'm going into this blind. Here's what I'm going to do. I'm going to read, just skim through all the questions here. There's actually only two for this, it seems, and just see what they want me to find. So this one says complete the model of fusion by placing the letter of the component into the correct position. And then this one says which claim best describes where energy is produced in the sun and how energy is released into space. Okay, so this one, it seems like I might need this, but we'll see how it goes. Sometimes it's good to read the questions and then go back up. So you can experiment with what works for you. So 4 components of fusion, labeled A, B, C, D, including models of the nuclei, are shown. So we got this, which we read, and that's then energy, and then helium-4 and helium-3. Complete the model by placing the letters, so A, B, C, D, into the correct position. All right, let's reread what it says. Different forms of the hydrogen and helium atoms contained in the sun's core, deuterium and the helium atom, are under very high temperature and pressure. These atoms combine to form helium and energy. So we want to start with this one and H. So we want to start with H, 2H, and 3He. That's what we need in the first 2 blanks. So that's this one. And then 3He is D. So that's how I got those 2. And then fusion happens, and it says we're definitely going to release energy. So definitely B. And then that leaves us with C as helium-4. And look, it's right there. So that worked. So that question there was literally directly in the reading. All right, number 2. Which claim best describes where energy is produced in the sun and how the energy is released into space? Okay, so we need to know where energy is produced and then how it's released. So let's see. Energy is produced. So this is how I would do this. Just read the first part of all the sentences first. Energy is produced in the core. Energy is produced in the photosphere. Energy is produced in the radiative zone. Energy is produced in the core. Let's figure out which one of those is true first. So let's see. Oh, look. It tells us information about the layer. Gives off energy. That's not where it's produced, though. So nuclear reactions occur. That's where it's produced. The nuclear reaction is going to produce the energy, right? So it's definitely the core. So now, why that's useful to do is we can get rid of 2 and 3 immediately, because that doesn't say it's produced in the core. And we kind of already said that the photosphere seems like it's going to give off the energy. So that's probably the answer there. So let's see. And then released by the photosphere. That looks good. This said it is directly released into space. So according to the chart, number 1, releasing from the photosphere, would actually be the right answer there. So honestly, if I were to rank these two, I would say this one is like a 3 out of 10 difficulty, and this one is probably like a 4 out of 10 difficulty. I thought these were both fair. Let's keep going. Scientists have identified an 11-year-old solar cycle. Okay. During this cycle, we'll highlight, there is an increase and decrease in the number of dark areas or sunspots on the sun's surface. Periods in the cycle with the highest numbers are called maxima, while the periods in the lower numbers are called minima. The graphs below show the total output of light energy from the entire disk of the sun, measured at the Earth in watts per meter squared, and some information about sunspots. Okay, so I just want to say it shows the output of light energy. Okay, so it seems like, you know, we got maximums here, right there, and the minimums there. They're just things I'm thinking about. I don't even know the questions yet, and it's the same thing here. So look, if you look at the graphs, these are corresponding, right? You could see they're in line, right? So the highest ones, we can conclude, based on this, that the highest number of sunspots is where there's the most solar irradiance, right? Most solar irradiance, highest sunspots. So let's see. Oh my gosh, there's another one. Model below shows photographs of the sun with active areas from 2008 to 2017. These areas indicate high frequency radiation emitted from the sun. Okay. The line on the model represents the number of sunspots during the same time period. So we're going to have number of sunspots here. So we could see in 2012 it was pretty high, and 2014 it was pretty high. Now looking up here, that might correspond to those graphs, but I don't know where this question's going yet, so we'll see. Use evidence from 2 graphs and the model. 2 graphs and the model, so all of it? Okay. To describe how the sun's irradiance varies with sunspot activity. Okay, I mean, we already saw 2008, it says it's low, right? So if we look at 2008, that's probably around here. So that works out. So they all correspond. So it's like a direct relationship for everything. So we're going to say, according to the graphs, the number of sunspots is directly related to the total solar irradiance. I don't know how to spell. Oh, it's in the question. Okay, total solar irradiance. And we're going to give an example of that. So we could say, for example, in 2014, there was high frequency radiation, high number of sunspots, and high solar irradiance. We'll just say in 2014, all 3 variables were high. And in 2008, they were all low. Okay. I didn't think that was that bad. I'll say that's a 5 out of 10. It wasn't horrible. All right, let's keep going. Which graph illustrates the projected pattern of the number of sunspots from 2020 to 2040 based on evidence from the graphs and the model? Okay, so we're going to extrapolate. So we're going to say what might happen from 2020 to 2040. So let's see. It did say, remember, up here, it's an 11-year cycle, right? So if it's the highest here, which they said was 2014-ish, right? If we go 2014, whoops, I'm in a highlighter. And it's an 11-year cycle. All we're going to do is we're going to keep adding 11 to that, and we're going to see if it works. So if you can't do that, just get your calculator out and add 2014 plus 11. So we got a maximum in 2025, and then we're going to add 11 to that. So we're going to have another maximum in 2036-ish. So let's see. So look at this. So this is, remember, this is the maximum projected. We need 2025 and 2036. So this doesn't have a 2025, but look, this does 2025, 2036. Boom. That was easy. That's like a 3 out of 10. As long as you read up there, and you know, we had that highlighted, that it was 11-year cycle, you could just add and figure it out. All right. As a star ages, the hydrogen in its core gets used up. The core begins to undergo a gravitational collapse and becomes more dense. The chart below shows some information about elements in the star. So immediately when I see collapse and things like that, I'm thinking of the reference table, right? Now remember, in the reference table, when you think of core collapse, you want to sort of think about this, right? This is the nucleosynthesis in a massive star diagram. So this might be helpful. We'll see, but you know, your brain should sort of trigger that if you know the reference table well enough. Okay. So we got elements produced during stellar evolution in some stars. So you could see it gives temperature, what was produced, all elements heavier than iron are going to be a star explodes. Which claim best describes the process of nucleosynthesis in a star? So, I mean, we hit that on the head. Do we need the chart? I don't know. Lighter elements are produced in a core near the end. No. Look, heavier is at the end. So that's out. Lighter elements are produced at lower temperatures during a supernova. No, because the lighter elements are all here, so there was no supernova at that point. Heavier elements are produced at the end of a star's lifespan as temperatures increase. Yeah, that sounds right. Heavier elements are produced at low temperatures. No. So this is the answer. I mean, that question honestly was super easy, so I'd say that's like a 2 out of 10, and we did not need the reference table. So far, no reference table needed. Okay, we're going on to the next cluster here. So we're at the power of water. We're going to highlight water in its many forms is unique to our planet. It's required for life as we know it and can be used for a wide variety of beneficial purposes such as recreation and generating electricity. That's probably what they're going to ask about. It could also be destructive and cause problems for humanity. Concrete's an important material that could be affected by water. We show how structures are built with concrete and rebar, which are metal rods to provide strength. Okay. An experiment was conducted on samples of concrete with and without rebar to see how freeze-thaw cycles affected the deformation of the concrete. Okay. This graph shows some information about the freeze-thaw experiment. A couple things here before we move on. Freeze-thaw cycles. You know what that means? It means the, frozen ground or frozen concrete, and thaw means to melt. So the problem is when you have materials that freeze and melt over and over again, this causes like cracking and things like that. Like it's going to break up the concrete. That's what deformation means. This means to be deformed means something's like being broken about it. So it would be tough like if you didn't know what those words meant. So it says how freeze-thaw cycles affect deformation, number of freeze-thaw cycles, and then deformation of concrete is here. And look, of course, they got to put high at the bottom and low at the top. So you could see the more freeze-thaw cycles there are, the higher the deformation. I mean, that makes sense. If there's more freezing and thawing, it's going to destroy your concrete. So it's actually a direct relationship. So we could say like more freeze thaw equals more deformation. And remember, we didn't even look at the questions yet. So like depending on, you know, what you like to do, it's probably a better strategy to look at the questions. First, describe a property of water that increases the deformation of concrete due to repeated freeze-thaw cycles. Okay. Also describe the amount of deformation when metal rebar is added compared to samples without the rebar. Okay, I didn't even notice that. I didn't look at this. So you can see the X's over here. There's less deformation with the rebar because it didn't go as high. So rebar is actually going to help. All right, so here's the kicker. Do you know the property of water that's going to cause the deformation with freeze-thaw cycles? So the answer to that question is that water expands when it freezes. That's the property of water they're looking for. So we're just going to say water expands when it freezes. And then the relative amount of deformation. So we're going to say more rebar equals lower deformation. So honestly, to know that specific water expands when it freezes was the challenge to here. This part was easy. So maybe I'll give this a 5 out of 10. It's fair. All right. Calthemite straws are deposits found on the underside of concrete structures such as parking garages. I don't know if I said that right, but that's what I'm going to pronounce it. Calthemites are not considered stalactites as they do not form naturally in cave and cavern system. The series of photographs below shows the growth of these straws measured in millimeters. Okay, so think of it like an icicle. You know, it's the same idea. Stalactites, icicles, calthemite. But this is with concrete. So the concrete's like dripping, you know, and it's like hardening at the end of the straw over and over and over again. The droplet is like moving down the straw and then, you know, hardening at the end, and it just grows and grows. Which claim correctly summarized the effect of water on the concrete in the parking structure producing the straws? Okay, let's see. Surface water evaporates minerals and transports them a short distance. The minerals then condense. There's no condensing, okay? Condensing is when gas turns to liquid. So that's not right. Surface water melts minerals. I don't think water is melting anything. The minerals then freeze? No. Surface water dissolves minerals? That sounds right. Water dissolves a lot of things. And then transports them a short distance. The minerals then precipitate, forming calthemite straws. That sounds correct. Surface water absorbs minerals, then transports them. The minerals then expand? No. So 7 is 3. I would say this one's kind of tricky. You could probably get rid of 1 and 2 and then 50-50 between 3 and 4. I could see people picking 4 because water absorbing minerals sounds like an enticing thing to pick. I would say this question is kind of challenging. We'll give it a 6. All right, we're going to go on. The power of water is utilized at Niagara Falls. 2 large power station facilities have been in operation there for decades. Water from the falls is diverted through pipes and tunnels upstream. So we'll just do that. The water is then run through turbines to generate electricity before it's released back to the river. Okay. Let's see if we can get this. Direction of river flow, direction of tunnel water flow. So the river flow is here. We're going to go like this. There's the river flowing. And then it's saying the tunnels are here. Did it say? Yeah. So it's diverted and diverted. And they go through these tunnels into these turbines. And then it goes back into the river. So that's what it's doing, and that's developing generating the electricity. Okay. How does the production of electricity by hydroelectric power plants at Niagara Falls, rather than burning fossil fuels, affect the atmosphere and change the climate? Obviously, burning fossil fuels is gonna be bad. Right? That's like where it's going with this. So let's see what it says. Hydroelectric power plants use a renewable resource, yes, that increases the atmospheric oxygen levels. No. And renewable resources don't negatively impact the climate. Hydroelectric power plants use a renewable resource, yes, that decreases the carbon dioxide levels, yes, which positively impacts our climate. This is correct. Hydroelectric power plants use a renewable resource that increases water vapor, no. It decreases water vapor, no. And this is like humid and arid. Arid means dry, by the way. That's a good word to know. So the answer here is 2, and this question's so easy, but it's a little bit of reading, so I'll give it a 3 out of 10. But that question was like real easy. The map shows some information about the changing position of the edge of the falls over time. Analyze data from the 2 maps to make a claim about how the construction of hydroelectric power plants and the diversion tunnels cause the rate of erosion at Horseshoe Falls to decrease. Okay, rate of erosion. So erosion, right, is how much material is being moved. How much material is being moved. So if you're diverting water, diversion means to make it go in a different direction, right? You're diverting water, obviously it's going to take away from the power of the initial river, which is going to make there be less overall erosion because you just moved half the water out, right? So the main river will be less powerful. So does it say analyze data from 2 maps to make a claim? So it doesn't say that we have to include evidence. So we could just say diverting water makes the main river less powerful, therefore reducing erosion. That's the answer. I mean, that question's middle of the road. I'm trying to think like a student here. I would say that's like a 5 out of 10. Like just diversion, knowing what that word means. If you don't know what the word diversion means, I mean, you could probably figure it out by this, the map. But if you don't know diversion, it makes this really difficult. All right. No source of electricity is 100% efficient. All sources require substantial monetary investment. That means it just requires a lot of money. To build structures, maintain them, employ workers, and establish a power grid, the energy return on investment calculation is a comparison of the amount of money invested to the amount of electricity produced. Okay? When the EROI value is too large, that means producing energy from that source is relatively easy. So large means it's easy and like cost-effective good. So that means if it's low, it's bad. So you could see hydroelectric right now, that's a really good return. And the other ones are pretty bad. Wind is second. Okay. Which statement accurately so let's just write down before we, this is good. So we know. Which statement accurately describes the return on investment for energy sources? The greatest return for a renewable energy source is approximately 5 times greater than... Okay, so now they're going to be asking for numbers, which is annoying. So we're going to have to get some numbers, but let's read through the choices. The greatest one for a non-renewable energy... Okay, now we need to determine which one's renewable and non-renewable. Okay, ready? Let's just do that real quick. This is non-renewable. This is non-renewable, nuclear, non-renewable, hydroelectric, renewable, geothermal, renewable, wind renewable, solar renewable. So like just to do that, I'm adding a +2 to the difficulty because you had to know 1, 2, 3, 4, 5, 6, 7 different forms of electricity, whether they're renewable, or non-renewable. That's kind of hard. So let's see. The greatest one for a non-renewable is the same as the smallest one for renewable. Oh my gosh, this is so annoying. The greatest one for non-renewable, let's see which one that would be. It'd be nuclear. Is the same as the smallest one for renewable, which would be geothermal. That's wrong. Nuclear is higher. The EROI for coal is the same as the wind. No. I mean, that was an easy choice to eliminate. The EROI for each renewable energy source is half for each non-renewable. That's not true. So really, this is probably right, but let's just check it. The greatest one for renewable, which is here. So now we got to get the numbers. So figure this is 75 and 100. So about halfway there. We'll call it 82-ish. Is it 5 times greater than the greatest one for non-renewable? The greatest one would be nuclear, which is half of 25. So we'll call it 13. 82 divided by 13. Which is about 6. So approximately 5. That's pretty good. Don't really like this question, to be honest. But it was kind of hard. So I'm gonna say this one was like a 7. All right, next cluster. Base your answers to questions 11 through 15 on the information below and on your knowledge of Earth and space science. Okay, so we're doing telescopes and the history of the universe. All right, let's see what we got. 2 space telescopes that are providing astronomers with information about the early universe are the Hubble Space Telescope, HST, and the James Webb Space Telescope, JWST. All right, so it's going to tell us about both of them. I'm guessing the HST orbits Earth at a distance of 540 kilometers and can observe the visible, ultraviolet, and infrared radiation. It contains cameras and spectrographs that break light into the colors of the spectrum for analysis of the elements found in stars. I'm just going to stop there and show you that you should be thinking of these charts on the reference table for this. Look, emission spectra, maybe the electromagnetic spectrum, so we might need these, but we'll see. Hubble has determined that the age of the universe to be a more precise date of 13.8 billion years ago and has photographed galaxies in all stages of evolution, even galaxies from the early universe. A central idea of the Big Bang theory is that the universe expanded rapidly and released energy. Scientists have been gathering evidence for this expansion and energy since 1920s. The photograph below shows 2 scientists in Jersey with the radio telescope aimed at outer space. The telescope was one of the first to record cosmic microwave background radiation coming from all directions in space. So, you should definitely know cosmic microwave background radiation, what it is at this point. It's some type of radiation from the Big Bang. It's very cold. We detect it in all directions. It's one of the proof of the Big Bang. Okay, so let's see how many questions there are for this. Just one, and then about wavelength. And then we have one about, looks like a constellation. So we got 4 questions on this one. This one's about gravity. We're still in this one, gravity. Kepler's laws. Wow. Okay. We'll just see where it's going. All right, let's go see. Go back up. All right, which explanation of the cosmic microwave background radiation provides evidence for the Big Bang? Okay, so this is directly asking about cosmic microwave background radiation. I'm sure we're going to need some background knowledge, but we'll see. Since the cosmic microwave background radiation was detected coming from all directions, it must be evidence for multiple explosions? No. But all directions is correct. Mathematical calculations showed that if the universe began with a Big Bang, it would have released a huge amount of energy in all directions and would be detected as cosmic microwave background radiation. I don't know. Kind of weird. We'll not cross it off yet, though. Cosmic microwave background radiation is produced by every star and galaxy? No. The presence of cosmic microwave background radiation is evidence for the energy released from dying stars that exploded? No. So it looks like for this one, the answer is going to be 2. And honestly, it's like not a great question per se, but it's pretty much like a 1, 3, and 4 are definitely wrong. And that's why it's mostly 2. It makes 2 right. So, I mean, I don't know. I think this is like a 4 out of 10, but I just don't like it. That's just my opinion. All right. The only evidence astronomers have for the first stars that formed is the electromagnetic radiation they left behind. Telescopes like Hubble can detect objects billions of light years away. Okay. So, electromagnetic radiation. We can detect objects billions of light years away, or billions of years back in time. The graph below shows some information about the first stars that formed after the Big Bang. Okay, let's see what it says. So radiation. So it seems like at this point here, we had the most intensity of ultraviolet radiation. And then in the middle, so we're at 300 million years after, 500 million years after. So at like 400 million years after, we got some visible light happening. Okay. We'll see what they ask about this. Describe how wavelengths of radiation from the first stars have changed since the Big Bang, and explain how this difference in wavelengths is evidence that the universe changed, or the universe changed since the Big Bang. I'm not really seeing, so I see the dotted line, but then it says the solid line is red shifted light of first stars. What solid line? Is it this flat line? Or is it the waves? Like, where is this? It's terrible. I don't get why they did this. It's bad. Let's just try to answer this. So, describe how the wavelengths of emitted radiation have changed since the Big Bang. Okay, so look at the emitted radiation here. Difference in wavelength. So this was all short waves, and this is long wave. That's where it's going with this. Over time, the universe had more long wavelengths. How the universe changed. So, explain how this difference in wavelengths is evidence for how the universe changed since the Big Bang. So, the universe changed since the Big Bang because it expanded. So, what they're getting at here is they want you to understand that as the universe expanded, the wavelengths of light were stretched with the expansion in the universe, which is why the wavelength is larger. So how it changed? The universe expanded. That's it. The question itself, honestly, is middle of the road to me. I would say maybe this one's kind of hard, so maybe we'll say it's a 6. But the chart is terrible. I don't like this. I don't understand this. I'm assuming it's about the waves, but it's really misleading. All right. One of the oldest stars ever observed by HST is classified as a giant star called the Methuselah. How do you say that? Methuselah. Okay. Is the oldest star, one of the oldest stars in our galaxy. It's believed to be almost as old as the universe itself. Based on this composition, scientists do not believe it's one of the first stars, though. Okay. So it's old, but not one of the first. Which statement correctly explains why the composition of a massive star, so composition, what it's made of, provides evidence that it's not one of the first stars that formed. All right, let's see. Methuselah is composed of 100% helium, but the first stars were composed of 75% hydrogen and 25% iron. Okay, stars. So no, it's not going to be composed of iron. Iron forms at the very end of the life of a star. So I would say that's probably wrong. Methuselah is composed of hydrogen and helium and some trace heavy elements, but the first stars contains a greater percentage of heavy elements. No. So number 3 says the first stars were composed of 100% hydrogen, but Methuselah is composed of 50% hydrogen and 50% helium. The first stars were composed of 75% hydrogen and 25% helium, but Methuselah also contains metals of heavier elements in its core. The problem I have with this is that where's the data for the composition of the star? So basically, the second part of this doesn't matter. That's what's horrible about this question, because they don't tell you what the star is made of, what's in it right now. So we cannot determine this. So the whole question, the correct answer, which is either 3 or 4, is only based on the first part, because we don't know the second part, which means this is a terrible question. It's stupid. The first stars were composed of 100% hydrogen. Is that completely true? Or were the first stars composed of 75% hydrogen and 25% helium? So the answer to this is that it's 4. The first stars were composed of 75% hydrogen and 25% helium. That's the only part you actually had to know about this. I thought this is the worst question so far. Like, at this point, they don't even need the second part. Because it doesn't matter, because once you determined that first part, it was automatically the right answer, because you can't get the composition of the star. So that's like assumption. So this is terrible. So, and it's so specific. It's like such a specific fact. So I don't even want to rate it, because I hate the question. So it's like, to me, it's like an unfair question. So I would say this is like a 8 out of 10, mostly because of how unfair it is, my opinion. All right. The model represents the locations of the HST orbit and the moon's orbit around the Earth. The moon's orbital distance varies from approximately 363,000 to 405,000, and that's because it's an elliptical orbit. So remember, an elliptical orbit means there's one point it's further away and one point it is closer, right? Because it's not a perfect circle. Okay. The orbital motions of satellites are determined by the strength of gravitational field at the location. The model below shows the formula to calculate the strength of the field. So there's the gravitational field, gravity formula. Okay. Based on the field model, use the word to complete the passage by matching the correct terms. Okay. Let's just try it. Compared to the average distance of the Earth and the Moon, the distance from the Earth to the HST is... So let's see. It's way shorter. So look, HST is so much closer than the Moon. The average distance is less. As a result, the gravitational field strength at the location of HST should be greater because it's closer to the Earth. The closer you are to the body in space, the higher the gravity. Therefore, in order to remain in stable orbit, the orbital period of HST must be blank than the period of the Moon. It's less. So the orbital period here is the time it takes to go around. To revolve once, right? The orbital period. If it's closer, the HST has to have should be a less orbital period. So that one should be 14 less, greater, less. That was fine. I just call that a 5 out of 10. It's all good. The next question says, based on the model of Kepler's laws, which graph correctly represents the relative orbital speed of the HST and the Moon as the two satellites orbit Earth twice? Okay, so twice is interesting. So we have to do 2 rounds of this. And we know a couple of things. The HST is close, and the Moon is further, right? So the speed is going to be higher where it's closer. So this is going to go faster, and this is going to go slower. So based on this, it seems like if we go up here, the HST, right, this is saying it's 540 kilometers into space consistently. That's what that is saying. So therefore, the speed of the HST should be completely the same because it's never going to be more than 540 kilometers away from it or closer. The Moon, however, is sometimes closer and sometimes further. So that means that is going to vary. So the HST is going to be flatlined, and it's going to be faster because it's closer. So the answer to this is going to be 1. I think this question's tricky, honestly. So I would say this is probably, we'll go like a 6 out of 10 on this question. It's a little tricky, just because you had to go up and see that this was consistently 540 kilometers away, because really everything should orbit in ellipses. So to me, the first thing that I would say is it should both be wavy like that. But that's not the case in this question. So it's kind of tricky. All right. Next one. Base your answers to 16 through 20 on the information below. We got the horse latitudes. The historical term horse latitudes, and it tells you the areas at 30 north and 30 south latitude. So automatically seeing that latitude, I think to go to my reference table, and I think to go here. So now we're talking 30 north. I'll get my highlighter. Like this right here, and 30 south. Right? That's where my head goes immediately. Let's see what it says. Comes from the legend of the Spanish sailing ships that would often become stalled for days or even weeks when they encountered areas that usually experience calm winds, sunny skies, and little to no precipitation. Many of these ships carried horses to the Americas as part of their cargo. Unable to sail and resupply due to lack of wind, crews often ran low on drinking water. To conserve scarce water, sailors on these ships would sometimes throw the horses they were transporting overboard. Thus, the phrase horse latitudes was born. Okay. So we'll just say lack of wind, low on water, things like that. Which statement correctly identifies the air movement patterns associated with the wind horse latitudes? So I was right. So they do want us to use this. So this is actually our first question where we need to use the reference table legitimately. So if you look at this 30 north and 30 south, it's between a Hadley cell and a Ferrel cell. And you could see this is sinking air here. It's sinking, the hours are sinking towards the Earth. So I think that's the first thing we had to identify. See, ascending or descending. So we want to say it's descending air, so that's wrong. And that's wrong. Before converging or diverging at the surface. So converging means coming together and diverging means separating. So we could see, watch, look, out and out. So it's going to be diverging at the surface. You could see this area would be converging at the surface because the hours are going towards each other. So we want diverging. So we'll go back. This is the answer. 16 is 4. And I thought that was really easy. So we're going to say this is about like a 3 out of 10. Easy question. All right, we got air mass source regions. Okay, so they do tell you what these codes mean, which is half the battle right there. So you definitely have to know continental means dry and polar means cold. Tropical is warm. Maritime means wet or humid, and then Arctic is very cold. Equatorial is very hot. And then we defined everything. Okay? Which winds drive the movement of a continental tropical air mass? So we need a continental tropical. So that's dry and hot air across Earth's surface away from the horse latitudes towards 60 north. So that means we're going away from 30 towards 60 north. So we're going that way. And we want continental tropical, which is here. So what's going to move from 30 to 60 north? And it starts to do winds. So now we got to go back to that and we got to see here. So from 30 to 60 north, we're going like this. Away and up north. So it looks like the westerlies here are going to be the ones that we want because they come from the west. So this is actually the prevailing westerlies, the southwesterlies, which is our wind belt. So it's going to be move CT from the northeast to the southwest. No, we're going to go from the southwest to the northeast. Yeah, 4. So that question was pretty easy. I would say that's a 4 out of 10. Prevailing southwesterlies are like the one wind belt. That's like the main important one because that goes over the United States. All right. Utica, New York is located approximately 43 degrees north. Okay, so right now I'm going to the reference table. Let's actually, I just want to keep track somehow. So far, we got 2 reference table questions. We got 1, and then this one was 2. 2 reference table questions. Okay. So now we're going to Utica, New York. I'm going to the reference table, and I want to go to Utica, New York. So I'm going to go to the New York State map with the cities on it. All right, so it wants us to go to Utica, which is going to be 43 north. So that's this line here. And we got Utica right there. Okay, so now let's go back and see what the question is going to be about. In the model below, Utica is influenced by a cold, dry air mass, A. Okay, a warm, moist air mass, B, that originated along the east coast of the United States enters the region. The model shows these 2 air masses interacting near Utica. Identify each air mass using the 2-letter code. Wow, this is so easy. So this one is going to be cold and dry. So it literally, we did that. So that's going to be CP. And then warm and moist is going to be MT. Easy. This is the easiest question so far. 1 out of 10. Also place a check marks in the box that indicates the resulting change in weather conditions over the next few hours. So, okay. So if this, it needs to know about CP air masses. Okay, I didn't know this table was there, so we're going to add 2 points to this because you have to know what type of weather each of these bring. So CP is coming in, so we're going to have more cloud cover, more precipitation, and colder air. CP generally brings storms. So that's going to be the answer to that one. So I would say that's like a 3 out of 10. The Bermuda high pressure system forms in the horse latitude region of the North Atlantic Ocean. Air circulation around the margins of the Bermuda High is known as a steering flow and can influence a hurricane storm track. Okay, so we're just moving the hurricane, right? Up this way. Sometimes there, sometimes there. Meteorologists analyze the position and strength of the high pressure system to make prediction about the storm track and determine where the hurricane will make landfall. The map shows some information about this. So this is the weaker Bermuda High and a stronger Bermuda High. So the high pressure, if it's stronger here, the hurricane's going to track more south and hit like Louisiana. If it's more north, it's going to hit like North Carolina. So, which correctly compares the characteristics of 2 to 1 and its associated high? Okay. So we know something. If it's a high pressure, it's going to be outwards and clockwise. So definitely clockwise. So we're going to get rid of the counterclockwise. That would be a low pressure. And the way you remember this is LICC is low inwards counterclockwise, and then HOC is high outwards and clockwise. So let's see what so now we're between 1 and 2. Steering flow, storm track. And we're comparing the characteristics of 2 to 1. So 2, it's saying this is going to be the information of 2. So if it's 2, it's going to be farther south than west, or, oh, so it's always farther south than west, okay. West then north is the answer, because we're going to go west first, or we should be on this one, west first, then north. And then it's clockwise and strong. So it looks like 19 is going to be 1. It's okay, this question, but it's kind of confusing, honestly. I would say this is kind of hard. I'd say it's a 7 out of 10. It's not a bad question per se, but it's kind of hard. All right, we got a hurricane and tropical storms. We got a graph relationship between time after landfall and the wind speed. So we could see, no matter what, it's always going down. And that makes sense because as the hurricane moves over land, it's going to get weaker and weaker wind speeds. And it's saying that obviously major, weak, and tropical storm, this is ranking in strength of wind as it is. So it makes sense that the major hurricane is going to start as the highest wind speed and go down. And then weak and tropical storms like a regular, like 75 mile an hour wind or whatever. 72, I don't remember what it is exactly. Okay, compare the pressure at 12 hours after landfall. Okay, let's get rid of my highlights so we can look at this. 12 hours after landfall to the pressure at 24 hours after landfall. And it wants pressure using the wind speed and landfall data. Okay, so here's what we got to know about this. As pressure goes up, wind speed goes down. That's what you had to know for this. So essentially, the lower the pressure, the faster the winds. So we could see the wind speed's going down, right? So the pressure is going to go up. And it says, using the wind speed and landfall data shown in your to justify the response. So you could say the wind speed dropped from 12 to 24 hours. Therefore, pressure increased. That's it. So obviously without you knowing this, you would not be able to get this. So I would say this is kind of hard. 7 out of 10. I could see some students going to try up here and try to find something about that relationship and you're not going to find it. So that's kind of hard. All right, 21 through 26. How did Earth get its water? Let's see. Scientists are unsure about where and how the Earth got its water. Early Earth lacked an atmosphere that was very hot. So water would not have formed. Our theory is that water was brought to Earth when comets collided with the Earth, since comets are made of frozen water, gases, and dust. Another theory centers around asteroids. Earth is believed to have formed from the clumping together of space debris. These early solar system materials contain the elements hydrogen and oxygen. Chemical proportions of the water found on the asteroids are similar, though different from the Earth's water. So far we have comets, asteroids, and then the last one, the most recent discoveries that come from studies of dust particles brought back to Earth from the Hokawa asteroid. The particles were found, so we'll just dust particles, to have water and an oxygen-hydrogen ion. The source of the hydrogen is believed to be from solar wind, hydrogen ions ejected from the sun, streaming through space and lodging onto the surface of the dust particles. These particles have been falling to the Earth since the solar system formed. The space dust is believed to have provided about 50% of the Earth's water. Okay, so they gave us 3 possibilities. The graph below shows the relative deuterium to hydrogen ratio in water found in solar system objects. Diamond symbols are measurements obtained by satellites. The dots are estimated values. Deuterium is a heavier form of hydrogen. This ratio is an important factor in determining where in the solar system an object formed and how asteroids, comets, and solar wind contributed. Okay, so let's just do this. Diamond symbols are from satellites, and dots are estimated values. Okay, there's just a lot of stuff here. So let's read the question before we try to look at this. A student makes a claim that the water on our planet is most similar to the water found on comets based on its DH ratio. So comets must be a major source of water on early Earth. Which statement, based on evidence from the graph, would refute this claim? So we're going to prove him wrong. The source of the water is the 4 largest planets in our solar system because these planets have water with higher DH ratios. The 4 largest planets are here. Okay, so they have low ratios. So that's not right. The water on, let's try to see if any of these are obviously correct before we deal with how much wording, and this is just a jumbled mess. The water on all the comets has the same DH ratios, except Halley. So Halley is not the source of water. Let's see. Comet, 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 Halley's comet. And it's saying the water on all this has the same ratios. Is wrong. They're different. 3. Many asteroids have water that is very close in DH ratios to Earth's oceans. Look, DH ratios in Earth's oceans, that's the flat line. So yeah, that's true. Many asteroids have the same as the Earth's ocean, so we're good so far. So asteroids could be a source of water on early Earth. Okay, that's possible. Water on the Enceladus has a similar DH ratio to comets. This. I mean, that's the moon. Enceladus is the moon. Similar, I guess? So Enceladus could also be a source of water for Earth. Okay, so that's kind of not that wrong, but 3 sounds better to me, and they didn't mention anything in the reading about Enceladus. They said it's probably, you know, asteroids or something like that. So I would say for this, if I was 50-50ing, I would go with 3. So I don't know. It's kind of a hard question, honestly. It's not horrible. Another 7 out of 10. I had a couple hard ones in a row there, unfortunately. Now, if you're sticking with me still so far, I appreciate it. I'm giving you, like, I'm talking out loud about how you would figure this out. So I hope, like, just hearing the thought process of someone going through these is helpful for you. Okay. Earth's first, by the way, if you know, you definitely should be trying these before you're listening to me, or else you're only getting half the amount of benefit from this. Okay. Earth's first significant atmosphere was formed from the release of gases from volcanic eruptions, when the mantle is believed to have been molten. Okay. Gases from the interior were released and accumulated into a gaseous surface layer trapped by gravitational force. Solar wind from the sun swept the light gases away, leaving behind heavier gases. The models below show the gas entering the atmosphere at 2 different times. So we got early Earth outgassing and present-day volcanic outgassing. So essentially the gas just comes out and goes into different parts of the world. The oceans, the plants, the atmosphere. Which statement correctly supported by evidence from the 2 models showing volcanic outgassing? All gases emitted from the Earth's early volcanoes escaped to outer space? No, because some went to the oceans. So that was easily wrong. The outgassing of water from Earth's interior contributed to the development of the early oceans. Probably. We'll not cross that off yet. Earth's early atmosphere contained significant amount of hydrogen and helium as a result from outgassing. So I don't see helium. I see hydrogen. So I would get rid of that one. Present-day volcanoes directly release oxygen that's used by marine and land plants, which in turn release carbon dioxide. So it seems like it's not directly releasing oxygen. I see it's releasing water that then is the oxygen and CO2 for the oxygen, but it's not directly releasing oxygen. So by doing process of elimination, we definitely say that 2 is the right answer. I don't think this was too hard. I'm going to call this a 4 out of 10. I don't hate that question. Okay, the water in the Earth's early oceans provided the necessary environment for life about 3 to 3.5 billion years ago. Organisms such as stromatolites were the earliest example of life on Earth and were capable of photosynthesis. Okay. From about 2 billion years ago to 500 million years ago, the Earth's atmosphere changed significantly, driven by an increase of many different life forms. Living and fossilized stromatolites can still be found today in Australia. Okay. 2.75 in Australia. Model of changes in atmospheric gases. So this is over billions of years, so you could see till recently from old, CO2 levels are going down and oxygen's going up. Construct an argument based on evidence in the model about how stromatolites in Earth's ocean caused the Earth's early atmosphere to evolve. Construct an argument based on evidence in the model. Okay, so we know, it says organisms such as stromatolites were the earliest example of life and were capable of photosynthesis. So we could see around 3 billion years ago, see this? 2.7-ish, that's when oxygen started increasing. So that's the evidence we're going to use. So we're going to say, according to the model, between 2.7 and 3 billion years ago, photosynthesis from stromatolites added necessary oxygen to the atmosphere. So we knew once we saw photosynthesis, we're going to create oxygen. And then to get the evidence, we just used the table somehow. So that's what you're going to have to do. 5 out of 10. Not terrible, but middle of the road. Say we haven't had that many easy ones recently. As life on Earth evolved and expanded onto land, fresh water became a vital resource. This is especially true for humans who use fresh water in a variety of ways. Okay. Humans have caused changes in land use through deforestation, agricultural expansion, and urbanization. So deforestation is cutting down trees, agricultural expansion is expanding farmlands, and urbanization is building cities. These changes can impact soil in both positive and negative ways. The graph shows some information about factors that affect erosion. Okay, runoff, soil erosion, and plant cover. So it says, as plant cover increased, soil erosion on this side is lower and runoff's lower. So plants, we could say, plants up meant erosion down and runoff down. So plants do two things. They stabilize the area and they also, take in water. So they're going to decrease erosion and runoff, which is great. So use the graph to complete the claims that describe how changes in the percentage of plant cover causes changes to runoff in the amount of soil eroded. So we already answered it, so we just kind of have to put it into words. Claim 1. As the percentage of plant cover, circle 1, increases, runoff will decrease. As the percent of plant cover increases, soil eroded will decrease. Well, I just jinxed it because that was so easy. This is literally like a 1 out of 10. I think this is so far like probably the easiest question on the test. Okay, in areas where human population density is high, managing freshwater availability is essential. A large underground store of water is called an aquifer. One of the most important ones on Long Island supplies 400 million gallons of water per day to over 2.8 million people. Okay, is this water cycle on Long Island aquifer model? I'm just looking down here. Okay, there's this one and this one. The cross-section represents the water cycle processes. Okay, so we got the water cycle: evaporation, transpiration, okay, infiltration, and sediment and rock layers that together make up a larger Long Island aquifer region are shown. Okay. A groundwater investigation is planned for water well B and well C from the cross-section. A scientist believes that well B will supply water at a faster rate than well C. Which one explains? Well, let's see if we can figure out why first. Well B is going to be faster than C. Okay, yeah, because it's a shorter distance. A shorter pipe. So yeah, well B will be faster than C. That's what we want. Oh, they're going for sediments. So we just want to make it go fast, right? I just saw the shorter pipe and thought that that was the answer. The sediments at the base of well B are less porous. That would be bad. Okay, so now we're doing porosity permeability. Okay, so in order to go fast, we want high porosity and high permeability. That would be good for pumping the water. If it's low porosity, that means the sediment is like clay, and if it's not permeable, that's bad too. It's going to be like stuck. So we want it to be very porous and very permeable. So let's see. We want B to be faster. So it's telling us about C, which is the opposite, which can also be true. So let's just read each one. Sediments at the base of B are less porous, with a higher permeability than well C. Those don't go together. The sediments of the base of well B are more porous, with a higher permeability. That is probably right. The sediments at the base of C are more porous, no. And the sediments are less porous with a higher permeability, no. So the answer to this is 2. So if you knew porosity and permeability and how it worked, this question, that was really easy. So I would say this is a 3 out of 10. A period of drought occurs when the amount of rainfall an area receives and the amount of precipitation that eventually infiltrates into the ground to reach an aquifer is greatly reduced. When Long Island aquifers experience periods of drought or overpumping, salt water from the Atlantic Ocean can intrude into the aquifer, polluting the fresh water. So they're pretty much saying a drought can make water from the Atlantic Ocean get into the aquifer. Describe how a period of drought would affect the depth of the water table. Okay, so first of all, the water table is how high the water level is underground. So if there's no rain, that water table is going to go down. Not going to be built up as high. Describe how this would affect residents supplied by water from well A more than B. Because the pipe is not long enough. Oh, so now my pipe thing gets into consideration. So we could say well A has a shorter pipe distance. So even if it dropped significantly, the water table, you know, A is gonna be cut off first. Even if it is like if it dropped to here, right? A is not being able to pump, but B can. So 26 was really easy. So I would say this is probably maybe a 4. Not bad. All right, we're on to the next cluster, Northern New York Pyrites Complex. Let's see what this is. The Pyrites Complex, located in New York State northwestern lowlands. Okay, so right off the bat, I'm going here. I'm like, okay, northwestern lowlands. Maybe over here? Or we're like here. That's the northwestern lowlands of New York State. So let's go read. Okay, represent a 1.35 to 1.21 billion-year-old fragment of ocean crust and upper mantle rock. Most of the rocks in the northwest lowlands are metamorphosed sedimentary and igneous rocks. The map below shows the location of pyrites complex. Oh, actually, see, this is the Adirondack Mountains, so really I was wrong. It's here. We're up here. Somewhere. That might not even matter, so we'll see. The map below shows the location of the pyrites complex within the northwest lowland. Body of water is shown in black. Okay. Great. Models A, B, C, and D represent the formation of the pyrites complex. Arrows indicate the direction of plate motion. Wow, okay, plate tectonics question. Okay, so we got faults. We got magma. And then I'm just looking to see immediately, I'm like, okay, what's different from A and B? What happened? We spread out. So see this? So this got wider. You could see literally it's wider than the top graph. And then we went in again. And then we went in again. Basin shrinks, is uplifted, and fills with upper marble. So we spread out, and then we went in. We diverged, then we converged. Okay, let's see what it wants to know. Use one of the formation of pyrites models to identify one geologic process responsible for the cycling of matter that contributed to the formation of the complex. Cycling of matter. Okay, so this. The arrows, that's the cycling of matter. So we're going to say B or A is the best because that cycling of matter is right there calling convection. When you see cycle, you want to think of something like moving material. So that's the convection currents. So I'm going to go with B just because I want to. And convection is the process. So that. That should be it. Okay, so I mean, that was not that bad. I would say that's a 4 again. 28. Student made a chart of constructive and destructive geologic processes from information shown in the formation of the pyrites complex models. Okay. Which table shows an additional process that's classified correctly? Classified means grouped and can be added to the table. All right, so let's just see something. Constructive, that's building up something. Destructive is to destroy. If something's shrinking, that's destructive, so that's not constructing. Destructive, faults first appear along the sides of the ocean basin. So faults are destructive. They're going to destroy stuff. That's possible. Constructive, granite and lower marble are uplifted. It's also possible. We'll think about that. Destructive. The basin fills with upper marble. That's constructive. Okay, so now we're between 2 and 3. Destruction. Faults appearing. It's not really destroying anything yet. You're cracking the area. Maybe that could be destructive. Constructive. Granite and lower marble are uplifted. I don't know if that's better. Uplifting is just moving it, right? It's not constructing it necessarily. So I think that based on all that, I'm gonna go. These two are like kind of weird. Faults first appear. Could you say that's constructive? Because you're developing the faults? Let's see this. New ocean crust formed. Intrusive rock rise to surface is constructive. Look, that makes this right. This is granite and lower marble uplifting. That's more right because of this right there. So I'm going to go with 3. I don't like this question because this is throwing me off a little bit. I mean, maybe you could tell me in the comment why that would be, why that wouldn't be right, but it's a little weird. I'm going to go with 3. I'm going to say this question's kind of hard, so I'm going to say 6 out of 10 on that one. It's kind of hard. Actually, I'm going to go with a 7 out of 10 on that one. All right. The flowchart below shows 4 geologic stages that led to the formation of the pyrites complex. The second one was left blank. Oh, well, of course. Volcanism builds the basin 1.3 billion years ago. We're going to see if we can do something here. Let's just go by the times. 1.3, blank. 1.21, present. Does it follow that? 1.3, blank. 1. It doesn't work. 1.21. So this might be this, 1.27. That could be 1.27. Maybe. Let's see. Based on the evidence, which process correctly identifies the missing stage? Quartzite is formed from lower marble. The ocean floor continues to form and widens. Faults move the granite beneath the basin. Divergence cause the ocean to become narrower and shallower. First of all, if divergence is going to make it bigger. So I think 4 is out, but let's go look. So we're looking at stage 2. The ocean's going to expand. The ocean expanded. So 4 is out. Let's just go back down because I just want to get rid of it. Okay, now faults move granite beneath the basin. I'm just going to go one by one because I can't remember. Did the faults move granite beneath the basin? No, the granite's up here. So no, that never happened. Did the ocean floor continue to widen? Yes. It's 2. We'll just make sure quartzite is formed. No, that happened way earlier. So it's 2. That question was easy. I'd give this a 3. Okay. The model below pairs tectonic locations with metal deposits that form within them. I have to tell you, I've been doing this test for a while now, obviously, if you're sticking with me. I'm getting tired. So as a student, this is like just a lot. Like, you need some serious endurance to get through this. It's a lot. Like, I need to go sit on the couch after taking this. Need a break. The model below pairs locate, and plus I have a coffee. So I don't think you could drink coffee during the test. Tectonic locations where mineral and metals deposits form. I'm not even looking at this yet. Let's just see the question. Based on the model above, identify 2 tectonic settings in which pyrite forms with zinc and copper. Copper and zinc. Zinc and copper. Copper. Zinc and copper. Why don't I see anything to do with pyrite? Identify the 2 tectonic settings in which pyrite forms in association with zinc and copper. Let's just see. Really, it can only be mid-ocean ridge. We'll go through these. Back arc basin and mid-ocean ridge. Back arc basin's correct. Mid-ocean, that's automatically right. Fore arc basin, zinc and copper, yeah. And magmatic arc. No, there's no zinc there, so that's wrong. Mid-ocean ridge and granitic plutons. Granitic plutons here, no. Mid-ocean ridge, yes. Subduction zone and fore arc basins, no, yes. It's 1. See, like that, there was way too much right here. There's too much for me to interpret. So I went down to look at the question and realized that the question is actually super easy. And I'm glad I didn't waste my time trying to figure out what this was looking at. And I just, was able to use it based on the question. So I really think, if you take anything away from this, go down and read the questions first. at least one question. Read one question and then go look at the chart. Then read the next question and go look at the chart. You know, go like that. You don't have to read every question in the cluster and then look at the chart because you're not going to remember everything. Okay, so this I would say is so easy. This is I'm actually going to call this a 1 out of 10. I think this is ridiculously easy. All right, 31 through 35, Earth, Moon. There's a lot of astronomy on this one. All right, Earth, Moon history. About 4 billion years ago, the moon was very close to Earth. The Earth may have been rotating at a much faster rate than today. It's estimated that each Earth day may have been 6 to 8 hours long. When calculated, would result in a year of 1,400 days. The force that caused the tides on the Earth created tidal friction, which over time slowed the Earth's rotation, causing Earth's days to become about 24 hours long. So it's saying the tides slowed the Earth's rotation. As the rate of rotation went down, the moon continued to move farther away, an average rate of 3.8 centimeters per year. The Earth orbits Earth at an average distance of this. The model and graphs show information about the tides. And nothing crazy here. Observe tides at Montauk Harbor. So, I mean, they can say, here's the low, here's the low, here's the high, here's the high. Okay. So if we were to just go down, that's here, that one's here, that one's here, and that one's about there. Okay, so let's see. Which row in the table correctly identifies the evidence and explanation for the observed cyclic change in tides at Montauk Harbor? Okay, it's not the Earth's revolution around the sun making the tides. The Earth's rotation is the answer. The moon's revolution around the Earth is not the answer. So now we're between... Oh, it's not the moon's rotation either. That automatically gave the answer. And they're about 12 hours apart. Yeah, this was very easy. I'll say a 2 just because you got to read a lot. But it's so easy. Determine... Okay, here we go. A little math. In centimeters, how much further away from the Earth the moon's average orbit will be 1,000 years from the present day, and explain why this change will not significantly affect the moon's period of revolution around the Earth. Okay, let's do one thing at a time here, because even I'm like, ugh. All right, we just got to get the rate of change, which said 3.8 centimeters per year. So that's easy. So 3.8 centimeters per year times 1,000. You could just move the decimal 3 spots, or you can just put it in your calculator. So you're going to get 3,800 centimeters. 3,800 centimeters is not a big enough difference to affect how fast the moon is going to go around the Earth. So this is too small to change the speed due to gravity. I mean, I feel like that's all you have to do. I mean, I didn't think that was that hard, but there's a little math involved, so some students hate math, so I'll say it's a 4. I honestly think that was a 3, but I'll give it the extra just because you had to do a little math. All right, sun and moon. Sun at perihelion, sun at aphelion, moon at perigee, moon at apogee. Okay, so these words, ready? Perihelion, that's the closest the Earth is to the sun. This is the furthest. This is the closest the moon is to the Earth, and this is the furthest. So they're showing this is smaller when it's further away. This is larger. This is smaller when we're further away, and this is larger. And it shows that distance is higher. Closer. Right? So that's there. And then the diameter is going to adjust too. It's just the diameter from how we view it because we're literally further away at the A's. See, A for away. That's how I remember it. Construct an explanation to support the claim that in about 700 million years, a total solar eclipse will be impossible. So in order to have a total eclipse, the moon has to block out the sun, right? So they're pretty much saying if the moon gets further and further away, it's going to be smaller and smaller, which will not cover up the entirety of the sun. That's the answer, but this question is ridiculous. I kind of like it though, honestly. In that time, the moon will be further, reducing the diameter we see from Earth, not blocking out the whole sun. Yeah. Honestly, guys, I think this question's awesome, but it's hard. So I'm going to give this I'll give it an 8 out of 10, but I really like it. I think it's my favorite question on the test. That's a very cool question. Props to whoever wrote that. That was good. I like it. All right. The measured angular diameter of a body is the angle that the diameter body makes with the Earth. Okay. Based on the information, which letter pair correctly completes the passage below? All right, let's just read it, and we'll look as we go. The change in the angular diameter of the moon during the moon's orbit is blank than the change in the sun. It's going to be more because it's closer to us. So it's going to change more. Oh, I'm doing this wrong. So A is greater than, so it's either going to be this or this one. And then, because the moon's orbit is inferred to be, first of all, let's get B. Watch this. Watch how we're going to do this. The moon's orbit is less elliptical than the Earth's orbit, so we got to just check that. We're going to go here. So technically you need this. Earth's eccentricity is 0.017, and the Earth's moon is 0.55, so it's more. The moon's eccentricity is more, which means if this is the answer, 1 or 2 is the answer, just based on the reference table. So this is our third reference table question, because we needed that eccentricity, or eccentricity, however you want to say it. The change in the angular diameter of the moon during the orbit of the moon is, let's go back up here. Oh, the measured angular diameter is the angle that the diameter of the body makes as seen from Earth. So it's going to change. The change is going to be greater. Yeah, it's going to change more often because it's more elliptical. So, honestly, this is very confusing wording to me. So I'm going to, it was easy, but it's confusing wording. So I'm actually going to say this is a 7 out of 10. Plus you had to go on the reference table. So that was hard. It's an easy question, but they made it hard with the way they asked it. Easy concept. All right. Going on. Astronomers theorize that the moon formed as a result of a collision between Earth and another planet. The debris created during this collision circulated around Earth and formed the moon. Okay. Evidence for the age of the moon is found in zircon, a mineral found in lunar rocks. The mineral contains uranium-238. The table below shows some information about 4 rock samples taken from the surface. Using the table, identify the letter of the sample that provides evidence to support the claim that the moon is approximately 4.53 billion years old, and explain how it supports the claim. Okay, so this is going to be our 4th reference table question, because we need to know the half-life of uranium-238. So to do that, we're going to go here, and we're going to jump to the half-life page, which is going to be, where is it? Here. And here's uranium-238, and the half-life's 4.5 billion years old. Okay. So if it's 4.5 billion, and there it is, right there, the moon is about that old. So identify a letter of sample that provides evidence to support the claim. It's going to be this. Because this is, so it would be, if the half-life is 4.5 billion years old, there should be about 50% uranium remaining. So we're going to say it's the Highland crust. Wow. This is hard. This is like really hard question. I'm going to say this is an 8 out of 10. And explain how this evidence supports the claim. Because the half-life is 4.5 billion, and there is about 50% remaining. Yeah. That's hard. All right. I don't have anything else to say about it. It's a great question. It's a very great question, but it's hard. Okay. Base your answers to 36 through 40 on the information below and your knowledge of Earth and space science. Okay, dams and flood mitigation. Dams and other structures are often put in place in river systems to help reduce life and property losses to residents living near rivers due to flooding. Okay, so dams and prevent flooding. Dams are also built to generate electricity, so it's like a 2-in-1. The graph below shows river flow rates on the Kootenai River in Montana in meters per second. Okay, so this is like a high amount in this area for some reason. And then we have before dam construction and after dam construction. So you could see high amount there, and then it drops significantly, the flow rate, once the dam was put into place. But interestingly enough, over here, it was lower, and then after the dam was put into place, it went up. Which claim identifies a benefit of developing and managing, so benefit, the Libby Dam hydroelectric project after its construction? So why is it good? The river flow rates have increased for the entire year? No. The river flow rates have decreased during winter months. Is that true? No, it increased during winter months, so that's wrong. After dam construction, the river flow rates change less throughout the year and allowed for more control of electric generation. That's probably true. They're definitely changing less. This is insane. Insanely high before it was constructed. Now it's kind of like over here. So this is possible. After construction, the river rates changed more throughout the year. No. So 36 is the best answer, is 3. And this was pretty easy. I would say this is a 4. Okay. River ecosystem with the dam. See, again, like to me, we're 3/4 of the way through the test. This is so much information on here that I'm not even going to look at it right now. I'm going to go down and read the question and see if I can then use it to get the answer. Because it's just too much. Like, I'm not going to waste my energy right now trying to go through all of this to maybe not even have to use most of it. So we'll see. How many questions are there? 2 for this one. Okay. Which statement correctly identifies a relationship between the hydrosphere and the biosphere? So if you don't know this, hydrosphere is all the water and biosphere is the life. So are water and life in a river system with reduced water flow below a dam. Okay, let's just see how this goes. Lower water levels below the dam will lower the water table and will increase biodiversity of native fish and birds. The water table will rise and provide a benefit to agricultural areas. See, now already, I know that I'm going to have to just read this whole thing because it's such a specific question. So let's just look around. We're going to have to read this whole thing. All right, here we go. Ready? River ecosystem with a dam. Effects of low flows. Dams change the river flow and ecology downstream. Okay. There's a reservoir. There's a dam. And we're reducing the flow, which is going to create algal blooms. So dam created the algae. And then here, it blows this area up. Barriers to migration, loss of sediment transport. So if the fish can't get through anymore, and the sediment can't get through. Reduced biodiversity. Many native freshwater fish and birds are threatened with or at risk of extinction. Dry river channels in the delta. Shrinking habitat. Wetlands dry out and there's less available water. So far there's a lot of negatives. Regional authorities allocate water for hydroelectric generation, irrigation, drinking water, industrial, and other uses. That's good. Irrigation is the major use of the ground and surface water. There's a well. We got the water table. There's an aquifer down here. The water table declines. Some rivers are recharged by aquifers and some aquifers are recharged by rivers. Taking water from aquifers can reduce the water flow in rivers. Saltwater intrusion. Extracting the groundwater can cause salt water to move into the aquifers, making it unfit for irrigation. Okay, we did it. Which statement correctly identifies the relation between the hydrosphere and the biosphere in a river system with reduced water flow below a dam? So we're saying there is a dam. Okay, here we go. Lower water levels below the dam will lower the water table and will increase biodiversity. It's not going to increase biodiversity. They said it's going to decrease it, so that's out. The water table will rise. No. It says water table decline. Reduce oxygen levels in a stream will create algal blooms, which improve habitat for fish. It's definitely gonna... It says fish are threatened, so no. A decrease in water promotes saltwater intrusion, which is harmful. Yes. So in that one, we literally had to read the whole thing. But the only positive about this is that the answer just came right out of this. And you know, I don't know if you've noticed, look how much I'm highlighting, right? You need a highlighter. You absolutely have to highlight. It just makes you be able to keep track of everything so much easier, especially with being on page 42 of this test. By this point, you need it. So bring a yellow highlighter. Just go with yellow. It's like the best color to like pop. Don't get like blue or orange. Go get yourself a yellow highlighter, and it's like an absolutely mandatory tool. This question was actually easy, but at this point, so I did this for the June, every question is going to get +1 difficulty because of test fatigue. So this is normally a 3. I'm going to put it up to a 4 because we're tired. It's sad to say, honestly. Use the model to construct a claim about the amount of coastal sediment deposited by a river system before and after the dam is constructed. Okay, well, it said that here. Loss of sediment transport. Use the model to construct a claim. Okay, so we could say constructing dams reduces. We're just going to copy exactly what it said. We'll say causes loss of sediment transport. That's it. That was easy. 2 out of 10. All right, going on. Diagrams below show a river system before and after being dammed to create a reservoir. Arrows indicate direction of flow of the river from upstream to downstream. Okay. Free-flowing river. I don't know what the dots are yet. And we're going this way. River with a dam. So they dammed it, and look what happened to the river. This very much expanded. Fish spawning and rearing habitat. So look, there are all the fish habitats, and now they're gone. so it was negative to fish. Based on the river ecosystem, which evidence-based statement correctly identifies how the availability of fish spawning habitats has influenced the fishing above the dam? Dams increase water levels upstream, decreasing the fish spawning and decreasing opportunities. Probably right. Dams increase dissolved oxygen downstream. They didn't say anything about that. Dams decrease water levels upstream. No. Dams decrease dissolved oxygen downstream. I mean, that was so easy. So I would say this is like a 2. Remember, it was probably a 1, but I added 1 because we're tired. Some residents in an area impacted by flooding have decided... By the way, I just want to go back. Upstream means like up here, like in the beginning of the stream. And downstream is like over here. Same with here, downstream, upstream. Okay. Some residents in coastal areas impacted by flooding have decided to place their existing home on stilts. So flooding, we got the stilts. Above flood water levels, the data table shows some information about flood damage. So, okay, 6 inches of flood is that much damage, and 48 is that much damage. They're going to ask me to do some math. Okay, we got a home on stilts. Use the cost of flood damage in a 25 square foot home to calculate how much a homeowner could potentially save after spending $56,000 to raise their 2,500 square foot home to avoid being impacted by a 24-inch flood. Oh my god. 24-inch flood is $87,326, so we're going to go... This is so stupid. $87,326, and they put in $56,250, and we're going to subtract it. So get your calculator. And they would save $31,076. Why? This is the 1 out of 10 question. I don't know why they put it on. Okay. They must have like literally ran out of ideas. Okay. Base your answers for 41 through 45 on the information below. New York State fossils of note. New York State fossil below is a Silurian age Eurypterid called Eurypteris remipus. This fossil, so first of all, Silurian and then a fossil, I would be going to my reference table and being like, okay, we're probably on this chart. Yeah, so there's my, Eurypteris here, and then we're in the Silurian, so maybe like some point here. But who knows, maybe we don't need it. We'll see. The fossil was originally believed to be a catfish before correctly being described as an arthropod, an invertebrate with a segmented exoskeleton and hinged appendages. Some Eurypterid appendages were used for walking, while other ones were used for swimming. It's a cool picture. Oh my gosh. Model below is a family-level tree, an evolutionary tree for various Eurypterids. The bars represent known temporal, which means time, ranges for each family. Some Eurypterid silhouettes are shown to scale with lines indicating their temporal placement in each family. Okay, this is like a headache, this chart. Okay, whatever. Let's see what the question is. Which row in the table correctly identifies the family, the age of the fossil, and the type of movement it's used for? All right, where does it say walking or swimming? Okay, so that's over here, see? Alright, so let's just go. So, this is how we're going to do this. We're going to just highlight. So, ready? Renipateridae. Is that 350 million years old? Let's find it. This thing. And where is the age of the fossil? Now, is it the end of the bar? Or was it right here? Or right there is the age? Is it 360 million years old of when it went extinct? Do they want? Or do they want the age of when it was there? 460 million years ago. I'm guessing it's that one. So age Because it's right here. So I guess this silhouette, do they want it right there? I guess. That's stupid. So it's about 460 or 360. So either way, I don't know which one it is yet. This is wrong. So we're going to say this is wrong. Okay, let's try the next one, and hopefully this answers itself. Terragatidae. Let's see. That one. So that's going to be right here. So that's like 400 million years ago. So that seems like it's wrong. We might have to go back if all of them end up being wrong in the age, because then we're doing the age wrong. Euryptidae, 420. Euryptidae, right here. It's like 405, so that probably wrong. Mycerterbra, I can't even pronounce these things. Myceteripidae, 355. Right here. 355. That one hit. Is it swimming? Let's see. Where is this thing? This thing goes here. Developed ability to swim. But it's not a swimmer. No. Oh, wait. Developed ability to walk. Developed ability for swimming. It's not a swimmer. Uh-oh. Alright, well, that's a problem. So let's go redo this. The Rhenopterid, is that 350 if we go to the exact spot? If it's right there? No. Is Pterigete 330? No. Is Euryptidae 420? No. Oh wait, it's right here. Is that swimming? I think this is it. Oh, that question is horrible. Especially at this point. You know? This question's horrible. Because it's not exactly, like it doesn't, the temporal ranges for each family. But it's saying how old is the fossil. Why? And there's two of them on this one. I hated this question. It's a terrible question. So I'm going to rate this 8 out of 10, mostly because it's horrible. All right, use information from the model to describe the temporal ranges of a fossilized Eurypterid that lived in a deep marine environment compared to those that lived in freshwater. Okay, look, I saw this before. Deep marine, freshwater. Dark versus white. So that I'm assuming that's the bars. And then this is shallow marine, so dark. Where's the white bars? White. Oh, no, that's not a white bar. It's got to be totally white. So white. White. So I think the white bars are more recent. Yeah, that's what's happening. The dark bars are to the left, see they're older, and the white bars are to the right side, which are younger. And the temporal ranges are much longer for the white ones. So that's what we're really going to search for. Freshwater had longer temporal ranges. That was pretty easy, honestly. 3 out of 10 plus 1, 4 out of 10. 43. Base the evidence on the model. I just want to get out of this table. Which table correctly completes a passable? Evidence of the mass extinction of blank Eurypterid families can be inferred from the model. Walking, swimming. Evidence of the mass extinction of which ones? Oh. Probably here. That's where all of these died at the same time, the walking ones. Okay, so get rid of my so the walking ones all died at the same time. And it's probably at the end of the Devonian still, I'm assuming. Okay. And then after this, the majority of the remaining ones lived in A. And then there's the white bars, which is freshwater. So it's going to be 2. So again, this chart is very difficult to deal with, in my opinion. I'm going to give this a 6. But it is a reference table question, so that's like, well, part of it. I forget, I think we lost count, so like 5 or 6 reference table questions. One of the world's oldest fossil forests was found in the 1850s in Gilboa, New York. Okay. Preserved plant remains were unearthed at the Riverside Quarry dated to about 390 million years ago in the Devonian period. This was the time when land plants were evolving into forest ecosystems. 486 objects, root mounds, horizontal stems, and plant fragments were identified in the rock, including 2 types of trees. Okay. That tree was found and related to ferns. Okay, that stuff was also found. That stuff grew underground. These same fossil trees have also been found in Venezuela and Morocco. The map shows the location of land masses where the first ancient forests existed during the Devonian period. Okay, so 390 million years ago. Let's see what it wants to know. Which evidence from the map could be used to support an explanation for the presence of similar plants and tree fossils found in that area, New York, Morocco, and Venezuela? These 3 land masses are located next to each other. Does it show where they are? Venezuela. New York, Morocco. We don't need to highlight that. We're going to highlight. So I shouldn't have highlighted the names. I'm going to highlight the actual place. This is Venezuela, Morocco, and New York. That's where the line's pointing to. So there they are. These land masses were located next to each other. Yes. These were located in a similar climate zone. I mean, I guess they're not technically next to each other. They're close. Next to would be right next to each other. So they are in a similar climate area. That could be right. All of them were in the northern hemisphere? No, the equator's here. So they're in the southern hemisphere. So that one's wrong. They had tropical ecosystem that allowed for ancient forests to develop in mountainous areas. No, that's not a mountainous area. So it's probably 2. Because, yeah, they're not technically next to each other. That was pretty easy. I'm going to go 3 out of 10, but plus 1 for test fatigue, so it's a 4. Alright guys, we got 5 questions left. The image below shows the fossils found in sandstones and mudstones near Gilboa, New York, and an artist's reconstruction of this type of tree typically found in the Devonian forest. Okay. So there's a fossil, and then he drew what they thought it might look like. Based on the diagram, which row in the table below provides the correct evidence that accurately describes the height and environment of formation of the tree fossil? So, what? Look at this. So this is 1 meter. So they want you to use this line to figure out how many meters this would be. So you would have to literally mark this distance on a piece of paper and then see how many times you could fit it onto this picture. So I'm just going to do it on my computer screen. It's probably 9 meters. Yeah, it's really hard to measure on a computer screen, but it's this one. 9 meters and terrestrial environment of formation, I mean, it makes sense. But it's definitely 9. So go with 4. So just, I mean, it's so easy if you know how to just use the line to measure. So I'm going to say this is a 2 plus 1 test fatigue. 46 through 50. Atmospheric carbon dioxide. Okay, the chemistry of the oceans and coastal regions around the world are particularly vulnerable to changes in greenhouse gases. Carbon dioxide emissions and polluted waters enter the marine environment. The waters become more acidic and less suitable for certain species. The full extent of this threat to marine ecosystems by human activity is not well understood, but proactive efforts are needed to protect the well-being of New York State's marine ecosystems. Okay. We got like a keeling happening here. So yeah, so over time, CO2 went up. Air temperature also went up. Hopefully, this seems like it's going to be easy. Describe how CO2 levels have affected the flow of energy out of the atmosphere, and describe how this change has affected global climate. Okay. So, we're going to say, according to the graph, CO2 levels increased, so it traps more heat due to the greenhouse effect, causing temperatures to increase. It's literally like cookie cutter global climate change. This is like a super easy question. So I'm going to say this is a 2 plus 1, so this is a 3 out of 10. Okay, we got the pH scale. So just so you know, for pH scale, I mean, it tells you acidic is under 7 and alkaline is like a basic over 7. And it's saying from, look, it got more acidic. So pH dropped, and they said in the reading up here, remember, that the waters are becoming more acidic and less suitable for certain species. So we're going to remember that. The change in carbon dioxide level from till then has caused the waters around Australia to decrease in pH and increase acidity. 47 is so easy. This is a 1 out of 10 and plus 1, so that's a 2 out of 10. Again, this is question 48, and this is too much for me to deal with, so I'm just going to read the question. From the time in Model 1 to the time in Model 2, determine if the atmosphere CO2 entering the ocean and the ocean carbonate ions are projected to increase, decrease, or remain the same. Okay, if the atmospheric CO2 entering the ocean and the carbonate ions are projected to increase. Okay, let's see. Atmospheric CO2, there's 1, and now there's 3. So it seems like it's going to increase. Atmospheric CO2 entering is going to increase. Where's the ocean carbonate ions? Does the arrow show relative amounts? Yeah. So the arrow got thicker here, and then carbonate arrow got thinner. See? This went down. So you needed to know this. The thickness of the arrows indicates the amount. That was the key. So if you read that, this is a 1 out of 10, so it's a 2 out of 10 difficulty, 48. Use the information in the models to explain how the projected 2100 availability of carbonate ions will change and will affect the marine calcifiers. So since it's going to decrease, you're going to have smaller marine calcifiers. Availability of ions will decrease, so marine calcifiers will be smaller. That's it. Again, 2 out of 10, maybe. I mean, maybe, yeah, I'll call it a 3. Mineral weathering, which takes place over geologic timescales, is one of the main mechanisms Earth uses to recycle carbon dioxide. In a process called coastal carbon capture, a common volcanic mineral, olivine, is used to limit the impacts of CO2 on the hydrosphere. Olivine is mined from the earth, ground into sand-sized particles, and then transported to regions where it's spread along the coast. Once in the water, olivine sand will absorb hydrogen ions, gradually making the water less acidic and potentially protecting wildlife. In July 2022, this technique was performed at the eastern end of Long Island. Part of an ongoing research, the model shows some information about the coastal carbon capture process. Okay, blah, 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 blah. Let's read. Which claim correctly summarizes how the coastal carbon capture process is a solution that will reduce the impact of ocean acidification? Olivine will lower the pH. No, that's going to make it more acidic, so that's not good. Olivine will increase the pH, yes, and decrease ocean CO2 levels. So this is, let's just see, is it going to decrease the ocean levels or increase it? It says right here. Remove CO2 from the ocean. So it's going to be 2. I mean, that was pretty easy. We'll say a 3 plus 1, so we'll say it's a 4. All right, team. We did it. That was the August Regents, August 2025. If this was just my opinion, I would rate this test if 1 was extremely easy and 10 was the whole test was extremely hard. I would say that this test is probably a 6.5. That's my final rating. There was a couple of bad questions, but I would say this was doable. But again, test fatigue really is going to come into play here. I think it's too long still for kids. My opinion. I hope this video helped you and you followed along. I'm sorry it's just so long. This is a whole nother beast of a test, and it's just going to be, this is how it's going to go. So hopefully the explanations helped you. If it did, please drop a comment. Tell me what you thought. Tell me if you agree or disagree with some of my answers if you want, or what you thought, or if you have questions or anything like that. And like and subscribe and follow, and I'll post more stuff as we go. Good luck studying, and I'll see you on the next one.